Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the seismic refraction test, and I derived the equation for horizontal layering case, but I have derived the equation for two layer case. Now, I will discuss the equation for the multiple layer case and as well as for inclined layering case. So, for the multiple layer case, the first in the previous class I have discussed for two layer case. Now, if I discuss it for multiple layer case, so suppose this is layer 1, this is layer 2 and this is layer 3. Okay, let us take the 3 layer case. So, this is VP1, VP2 and VP3, and obviously condition is that VP3 should be greater than VP2 should be greater than VP1. As I mentioned, this is the condition. So, here my source is again A, okay, and then this is the refracted ray, and then it will be here, and this one is IC, and obviously sin IC is equal to VP1 divided by VP2, that we know. This is also IC, and this is my say one geophone position which is E. Now, there will be another layer. So, this will be the ray, then it will be away from the refracted, away from the normal, because this is also from low speed material to high speed material. So, now here this is IC1, I should say, because this is the IC1, the critical angle between layer 1 and layer 2. Okay. So, this is layer 1, this is layer 2, clear? Now, this will be here, this is critical angle, this is IC2, this is critical angle between layer 2 and the 3, okay. Now, again it will reflect like this, then again it will follow this path, and then finally it will go to that another geophone say K. Clear? So, now here IC2 is equal to, or sin IC2 is equal to VP2 by VP3, okay, and this angle is say I. This is I say. So, what will be sin I? Sin I will be VP1 by VP3. Okay. Now, how I am getting sin I is VP1 by VP3, because I know for this case. So, now here I know that sin I, that will be equal to VP1, that will be equal to sin IC2 VP2, okay. So, this is equal to VP2, and that will be equal to, here it is 90 degree. So, this will be sine 90 degree by Vp3. Okay. So, sine I divided by Vp1, that will be equal to sine IC2 by Vp2. This is Vp3. So, from here I will get that sine I, that will be Vp1 by Vp3. Okay. So, that will be Vp1 by Vp3. Similarly, sine IC2, that will be Vp2 by Vp3. That will be Vp2 by Vp3. Okay. So, now let us do the derivation. So, there will be direct ray. So, here also this part it will follow the Vp3. This part it is Vp2. Direct one is Vp1. This part Vp1. This one Vp1. This is Vp1. This is Vp2. Same as the previous case. Now, from here the TR reflected ray, that is from, say, this is C, this is D, so this is, say, G, H, I, J. So, if the reflected ray via A, C, D, B, D, E, A, C, D, E, that will be equal to, we know, that is the distance x or xn divided by Vp2 plus 2h1 root over Vp2 square minus Vp1 square divided by Vp1 Vp2. That I have already discussed in my previous class. Okay, so what is H1? H1 is the thickness of the top layer and H2 is the thickness of the second layer. Okay. Now, similar way I can derive, okay, similar way I can derive, also we can derive that A, G, H, I, J, K, the refracted ray traveling through this path, A, G, H, I, J, K, this one, that will be equal to Xn divided by Vp3 plus 2h1 root over Vp3 square minus Vp1 square divided by Vp3 into Vp1 plus 2h2 root over Vp3 square minus Vp1 square divided by Vp3 Vp2. So, this is Vp2. So, this is the two equations. So, that means here, and obviously there will be a direct equation is also there, that is Xn divided by Vp1. So, I have three equations now in this case. Okay. Now, if I plot, distance, that is x, to the time t, and that will be first arrival time. So, I will get, say, so you will see now there are three distinct change of the slope. So, now if I draw them, this is my first portion of the curve and this is the third portion of the curve, second and third. So, three changes of the slope. So now here this is equation number 1. This is equation number 1. This is equation number 2. And this is equation number 3. Okay. So slope of this first portion will give me VP1, that is the direct one. And slope of this one, this is give me the 1 by VP2. So this will give me 1 by VP2 and this one will give me 1 by VP3. This is equation. So this is also 1 by VP3, VP2, 1 by VP1. Now if I extend the first portion, so this one give me T01. If I extend the straight lines of the second portion, this will give me T02. Now from here, if from equation, this is 2. So equation 2, if I put T01, so this will give me T01. So this is xn will be 0. So it will be 2x1 h1 root over Vp2 square minus Vp1 square divided by Vp2 by Vp1, the same as the previous case that I have discussed. Now if I put T02 in equation number 3, this is in equation number 2, this is equation number 3. Okay, T02, this part will be 0. So this will be 2h1 root over Vp3 square minus Vp1 square divided by Vp3 Vp1, then plus 2h2 root over Vp3 square minus Vp2 square divided by Vp3 and Vp2. Okay. So from here Vp1, Vp2, Vp3 I will get from the slope, and the here in this equation T01 I will get from the graph, T02 also I will get from this curve, a graph, and then here only unknown is h1. Here only from this h1 I will put here, I will get only unknown is h2. So from these two cases I will get h1 and h2 and Vp1, Vp2, Vp3. It is not that only 3, I can do it for n number of layer. So it was this here, it will keep on changing the slope. There will be Vp1, Vp2, Vp3, then again it will change Vp4, again it will change Vp5. So n number of layer I can get the velocity and the thickness of n minus 1 number of layer. Clear? So I will get the velocity of n number of layer and thickness of n minus 1 number of layer. Okay. So this is my time intercept method. So now similar way I will get it for your the same way I can use your critical distance concept or method also. So this one will be xc, now xc1. Here it will be xc2. So what is xc1? Now if you place any geophone less than xc1, then the direct ray will reach first. Now if you place any geophone in between in greater than xc1 but in between xc1 and xc2, then this ACDE, this refracted ray will reach first. And if you placed any geophone greater than xc2, then this refracted ray along this path AGHIJK, that will reach first. Clear? And similar way you can use this critical distance concept also to determine H1 and H2 that I have discussed in the previous case. The similar way. Yeah, okay. So now if I start that, if I take that this equation number, this T02, okay. So now if I take this T02, now from this T02 you get that my T02 from here, if I simplify that, then I will get this expression of H2. So expression of H2 I will get from here. So from here, first I will get the expression of H1, say expression of H1 I will get that T01 Vp1 Vp2 now divided by 2 root over Vp2 square minus Vp1 square. Okay, so that expression of H1 I will get. Similarly, the expression of H2 I will get like if I rearrange this portion, then I will get the H2 is half T02 minus 2H1 root over Vp3 minus Vp1 square divided by Vp3 Vp1 then Vp3 Vp2 root over Vp3 square minus Vp2 square. Okay, so I will get this equation also. Okay. Now if I use the critical distance concept, with respect to second and third layer. Second and third layer, then this is my XC2. So second and third layer means I will equate equation number 2 and 3. So I will equate equation number 2 and 3. So if I equate equation number 2 and 3, it will be XC2 by Vp2 plus 2xH1 root over Vp2 square minus Vp1 square divided by Vp1 and Vp2, that will be equal to XC2 by Vp3 plus 2H1 root over Vp3 square minus Vp1 square divided by Vp3 and Vp1 plus 2H2 root over Vp3 square minus Vp2 square divided by Vp3 and Vp2. Okay. And now if I further simplify it or rearrange it, then I will get the expression of H2 like this, that XC2 divided by 2 root over Vp3 minus Vp2 divided by root over Vp3 plus Vp2 plus H1 by 2, H1 by Vp1 this is H1 by Vp1, then within bracket Vp3 root over Vp2 square minus Vp1 square minus Vp2 root over Vp3 square minus Vp1 square, then root over Vp3 square minus Vp2 square. Okay. So this is the expression of H2. Now from here I will give you the expression of thickness of kth layer or n number of layer. Okay. So kth layer, so this will be 2 is now replaced by k. Now this will be xck divided by 2, then root over, this is 3, your k is 2 now, this is 3, so it will be Vp k plus 1 minus Vp k, then root over Vp k plus 1 plus Vp k. So this part is common. So you can see after that it will keep on adding the layer, because if you see my previous case when I discuss about the 2 layer case, in critical distance concept you will get just one part is added. Now it is 2 parts. This Vp3, this is one part was added, now it is one part then another part. So this one keep on adding if you take n number of layers. So that's why I have to put a summation j is equal to 1 to k minus 1. Here it is k you are saying, but you can go for n also. Okay, but I am writing it with terms of k. So that means k number of layer. So now here it is H1 by Vp1. So H1 will be Hj. What is j? J is up to k minus 1. Remember that. We start from 1 to up to k minus 1. This is kj divided by Vpj. Okay. Then this is Vp3. Vp again k plus 1. 3 means 1 and 1 means j. That means k minus 1. Then root over Vp2 square. So Vp2 square means this is k is 2. So it will be Vpk square. Okay. Then it is 1. So this will be Vpj square. Okay. Because 1 means k is 2. Less than 2 means j. Greater than 1 k means it is plus. K plus something. This is j. Then minus Vp2. So this will be Vpk. Then root over. This will be Vp3. So Vpk plus 1 square. Then Vp1. So this will be Vpj square. Then root over Vp3, Vpk plus 1 square. Then minus Vp2. So Vpk square. So this is a general expression of thickness of the kth layer. So but remember that this is valid for if k greater than equal to 2. Okay, for k equal to 1, for the first this you can start from second layer onward. That means k greater than equal to 2. So that means k, H2, H3, H4, H5 and so on. But the H1 case you have to use these equation, or you can use the critical distance concept and equate this equation 1 and 2. So equation, if you equation 1 and 2, that means your critical distance with respect to first and second layers. So first and second layer. So first layer it was only xn by Vp1. So it will be xc1 by Vp1. Then that will be equal to xc2 by Vp2. xc2 by Vp2 plus 2 h1 then root over Vp2 square minus Vp1 square, then divided by Vp2 by Vp1. So from here, so for the first layer thickness calculation, you have to use these equations. You will get the, sorry, this is also Xu1. This is also Xu1. So Xu1 you will get from this plot. So this will be Xu1, you will get Vp1, you will get Vp2, only unknown is X1, H1. So that H1 you will get from these equation, Vp2 minus Vp1 square by Vp2 by Vp1. Okay. So that means the if it is your K is equal to 1 or first layer, then you have to use these equations, these expression to to determine the H1, or you can use these expression to determine the H1. But for K is equal to greater than equal to 2, you can use this general expression that I have given. Clear? So now, and Vp1, Vp2, Vp3, Vp4 you can get from the chart that I have discussed already. So now I will go for the refraction survey for incline layering. Okay. That is incline layering. So here if the layer is inclined, then how I will get that? Okay. So suppose this is the layer. Again I am drawing, this is the inclination, but direction of inclination will automatically come from the expression. Okay, like the reflection test also, the direction will automatically come. So now I am assuming this is the direction of inclination and this is the angle beta. Okay. So this is A. So that is this is my refracted ray. This is IC value. So say this is the distance and this is also IC value. So this is the position of the geophone E. This is A, this is C, this is say D. Okay. So it will follow this path. So this is layer 1. Its velocity is say Vp1. This is layer 2, velocity say Vp2. Okay. So this is our all the layers I have given. Now I will draw some construction lines. What are the construction lines? First I will draw a parallel line from the A and parallel to the boundary of two layers. So I will draw a parallel line. Then I will draw a perpendicular line from A to the boundary of the two layers. Similarly, I will draw another perpendicular line from the geophone E to the boundary of the layers. This is also perpendicular line. Okay, and then I will extend this line. So this one is say Z dash, and obviously this is say Z double dash. So this is the perpendicular distance between the any point to the boundary between the layers. Now, if you want to, okay, let me first draw these lines, complete this, extend this line, okay, and give the different names. Say, suppose this is A, this is F, okay, this is say A1, okay, this is say A2, and this is say A3, this is A4, fine. Now, what I am doing, that I am drawing another line, that is the vertical distance between any point and the layer boundary of these two layers. This is Z dash is the perpendicular distance, and H dash or H double dash is the vertical distance. So, if you know the Z dash, so Z double dash or Z dash, then you can easily determine the H1 or H double dash, because if you know the beta value. Okay. So, now if I complete this, so now this is beta, so obviously this one will also be beta because this is parallel. Then this is IC, this one is IC, this one is also IC. Okay. So, now again the condition is BP2 is greater than BP1. BP2 is greater than the BP1, and sin IC is equal to BP1 by BP2. Okay. Now, I have to start that derivation. So, I will just start the derivation. So, derivation is, first one is the direct ray, that will follow x by Vp1 if this distance is x, or you can write x, or you can write xn, anything if you want. Okay, you can write x or you can write xn. So, this is my equation number 1. Now, Tr, the reflected ray, it will follow this TAC plus TCD plus TDE, TDE, it will follow this path. Okay. Now, here this will follow with this velocity Vp2. Now, TAC, that will be equal to TAC, that will be equal to, again, this is AC, this is Z dash, and this is IC. So, this one is basically Z dash, this one is also Z dash. Okay, this one is also Z dash because this is parallel, and this is IC, this is Z dash. So, I will get this value as Z dash by cos IC. Z dash by cos IC is equal to AC. AC is equal to Z dash by cos IC, because your AC is equal to Z dash by cos IC, and then into BP1. So, that will give me the TAC. Now, TCD is basically 1 by Vp2, then in between A4, what is A4, then minus AA1 minus A2, A3 minus A3, A4. Okay, that distance I am taking A4, then I minus this distance, minus this distance, and minus this distance, so that I will get only A1, A2. CD is equal to A1, A2, that I am getting here. Okay, so now I will put that what is 1 by Vp. What is AA4? AA4 means this is AA4, yeah. AA4 is this one. What is AA4? Because if this form this triangle A4 and E, I will get that AA4 is equal to x cos beta, because this is beta, this is x. So from this triangle I will get this one as a x cos beta, this one as a x sin beta. Actually from the same triangle I will get that A4 E is equal to x sin beta. That I will use later on, okay. That I will use later on. This is x sin beta, this one is x sin beta, this one is x cos beta. So if AA4 is x cos beta, this will be x cos beta, then minus AA1, that will be simply z dash tan IC. This minus A2, A3, that will be simply same as z dash tan IC. Then minus A3, A4. So I know this one is x sin beta. This one is x sin beta. So now from triangle A3, A4 and E, I will get that A3, A4 that is equal to x sin beta into tan IC. Because this is IC, this is x sin beta. So this one will be x sin beta into tan IC. So this will be x sin beta into tan IC. Okay, now the last part, TDE. TDE I can write that is 1 by VP1 into DA3 plus A3E. DA3 plus A3E. Now this is 1 by VP1. DA3 will be how much? This is DA3. I know this is Z dash. This is I3. So DA3 will be simple Z dash cos IC. Okay. Then plus A3E. A3E. I know this is x sin beta. This is x sin beta. And this one will be x sin beta divided by cos IC. That will also come from this triangle, okay, from A3, A4, E triangle. This is x sin beta, then this one will be x sin beta by cos IC. Now I have to put all these value in the equation. So I'm just finishing this lecture here. So next class I will continue from here and I will finish this derivation, and then I will show you how we can determine the unknowns. Now what are the unknowns here? My unknowns are VP1, VP2, Z dash or Z double dash and the beta. So these unknowns I will get, how I will get, we will discuss in the next class. Thank you.